Our math adventure continues, and we are entering a new world of math, the world of rational numbers. What is a rational number? Well, it's simply a number that comes between two whole numbers or two integers. So we're talking about our decimals and our fractions. And we can name any rational number by using either the name of the decimal or the name of the fraction. So that means that we have to be able to go back and forth between the two. Now, what exactly is a rational number? Well, we know we have rational numbers when in decimal form, our decimal either terminates, which means it stops, or our decimal repeats in a pattern such as 0.363, 636, and so on. If the decimal doesn't terminate or repeat, then it is not a rational number. Those are called irrational numbers. We'll get to those sometime later. So what we're going to need to be able to do is go back and forth between the fraction name and the decimal name. So we're going to start off by taking a look at how do you take a fraction and rewrite it as a decimal. And there's an easy way to do it, kind of a medium way to do it, and a hard way to do it. So let's start with the easy way. All you have to do, look at the denominator. And we're looking to see if the denominator is a 10, 100, 1,000, and so forth. The reason why? It completely matches up with our decimal place value. So if we have a denominator that's a 10, that means that is matching up to our tenths place. If we have a denominator that's 100, well, that's matching up to our hundredths place. And notice I'm just doing a dotted line for each place value. And if we have a decimal that's 1,000, that's our thousandths place. Once we know the place value, all we have to do is take that numerator and place it into that place value. So 2 is placed right above that dash. 2/10 in decimal form is the same as 2/10 in fraction form. Now sometimes we're going to have more dashes than we do numbers. Well, that numerator always goes to the last place. So I'm going to place that 2, let's use blue, there, but I still have a dash I have to fill in, and we always just put a 0 there. And the same thing's going to apply if it's the thousandths. So I'm going to put my 2 at the very end, and I'm just going to place 2 zeros before it. That's the easiest way we can take any fraction and make it a decimal. Now sometimes we don't have fractions with denominators that are a 10, 100, or 1,000. So this is where we're going to come kind of to the medium way. We have an extra step here. So I take a look at these denominators and I think to myself, is there a way to get those denominators to be a 10, 100, or 1,000? Really, essentially, I'm just making equivalent fractions. Well, I take a look here and I see 5, and I think to myself, well, I know that 5 times 2 is 10. And whatever I do on the bottom, I'm going to do on the top. So 2 times 2 is 4. Now I'm in a place where I can make it a decimal of 4/10. And if I have, say, 100, well, or 20, I'm sorry, I know that 20 times 5 is 100. And whatever I do on the bottom, I do on the top. And I can easily change that into its decimal form. Sometimes, though, we'll have a denominator that there's nothing I can multiply it by that's going to give me a 10, 100, or 1,000. And that's our most difficult one. And it's really not that difficult if we remember that really this is a division bar in a fraction. Simply means 2 divided by 3. And we can then set it up as a division problem, putting our numerator on the inside, our denominator on the outside. Now I know it's going to be a decimal, so I'm expecting to have to put a decimal point in. So when I look at this, 3 cannot go into 2. So I put a 0 there, but then I add my decimal point. And then to move to the next place value position over, I annex a 0. Now 3 can go into 20, it goes 6 times. Because 6 times 3 is 18. I get a 2 as a remainder, but I want to move to that next place value position over, I annex a 0. And now I can see that a pattern is starting to develop, so I don't really need to continue it any further because I can just then rewrite this with my repeating bar over the top of that 6. So those are the 3 ways that we can take any fraction and make it a decimal. Now we have to be able to go to the other direction as well. So what if I have a decimal and I need to make it a fraction? Well, for a terminating decimal, it's pretty easy to do because all we do is we look at the place value position. So I know there's the tenths, there's the hundredths, there's the thousandths. And I can immediately put a denominator of 1,000. And I take a look at that number and that becomes my numerator. Now it doesn't mean that we're in lowest terms. I always have to look at that and see if I can reduce it by anything. And I look at this and I think, oh, I could divide both of these by 4. Because 324, well, I know 32 divided by 4 is 8, 4 divided by 4 is 1, and I know 1,000 divided by 4 is 250. That becomes my fraction that names the same thing as 324 thousandths. Now a repeating decimal, that's a bit harder. So what we're going to do is we're actually going to create an equation for the repeating decimal. So my first step, I want to take x and I just want to set it equal to that repeating pattern. Now I'm going to create my equation. So I'm going to say x equals 0.6 repeating. I want to pull out one of that pattern of the repeating numbers, which means I need to move that decimal point. And the way I move a decimal point is I multiply by powers of 10. So if I multiply this just by a power of 10 on this side, that's going to move that decimal point 1 place over. And so now I actually have 6 and 6 repeating. But the second I multiply by 10 on that side, I went out of balance. So in order to pull myself back into balance again, I need to multiply by 10 on the other side. So now I have 10x equals 6.6 repeating. All right, well, I don't want that repeating pattern anymore, but I know that I set x equal to that repeating pattern. So what I want to do is I want to subtract out that repeating pattern, but instantly I'm out of balance. So I have to subtract out the repeating pattern on this side as well. Well, how do I do that? Well, remember we set x equal to that repeating pattern. So I can subtract out a single x, and that's the same thing as taking out the repeating pattern. Well, what I'm left with now is 9x on this side, and on this side I'm just left with 6. Well, I'm not done yet because I need to get x by itself. So in order to get x all by itself, I'm going to use inverse operations. And this is 9 times x, so I'm going to divide by 9. Uh-oh, went out of balance. So how do I pull myself back into balance? Well, whatever I do on one side, I have to do on the other side. In the end, I'm left with x, which is what I wanted. And on this side, I actually have a fraction. Now it's not in lowest terms, so I need to make it into lowest terms. So I could divide both of these by 3, and I see that 0.6 repeating is the same as 2/3 as a fraction, and I challenge you to check this out. Go take a calculator, type in 2 divided by 3, and you're going to see that repeating pattern come out. Now it's your turn to do this adventure. Are you up for the challenge?